Today's topic is 8051 microcontroller. Before getting into the topic, you should understand the clear concept behind 8086 and 8051. 8086 is a microprocessor which is used to execute more number of tasks at a time. But in case of 8051, we are going for only application specific tasks. So in 8051, it is a microcontroller, incorporates all the features that are found in microprocessor. However, it has also added features to make a complete microcomputer system on its own. The microcontroller has built-in ROM, RAM, parallel input-output, serial input-output, counters and a clock circuit. Features of 8051. So it has 4096 bytes on-chip program memory, 128 byte on-chip data memory, 4 register banks, 128 user-defined software flags, 32 bidirectional input-output lines organized as 4 8-bit ports, 12 MHz of crystal and 2 multiple mode 16-bit timer counter, 2 level prioritized input structure, speed overflow reduction and parity computation, direct byte and bit addressability. So this is the pentagram 8051 has 4 ports, port 0, port 1, port 2 and port 3. Along with that, we are having multifunction pins like RXT, receiver, TXT, transmitter, INT0, INT1, interrupt 0, interrupt 1, timer 0, timer 1, read, write, external 1, 2, that is for crystal, and here we have EA access, that is external access, program, address latch enable, program store enable. Next comes internal block diagram of 8051. In internal block diagram, we are having a clock signal oscillator connection circuit with timing and control. Instruction register is along with your timing and control signal. All timing control operations done over here in this block, and we are having ALU block, arithmetic logical unit block, where it has two temporary register to get data from external memory or peripheral devices to your ALU. Here we have program status word, which is used to execute the status of the microcontroller. Operation status executed using 8-bit PSW, and we are having accumulator register, B register, RAM address register, RAM and 4 ports, port 0, port 2 and port 3, port 1 will be available along with the driver circuits. And moreover, we are having a timer circuit here and stack pointer, flash memory, program adjust incrementer, buffer, PC auto incrementer, program counter and DPTR. Next comes program memory organization. So program memory organization is predominantly working under a single pin EA bar. So when EA bar pin is high, program fetches to addresses 0000 through 0FFF are directed to the internal ROM, and program fetches to addresses 1000H through FFFFH are directed to external ROM and EEPROM. When EA bar is active low, all addresses fetched by program are directed to the external ROM or EEPROM. Next comes your data memory organization. Data memory organization, we are having 128 byte of internal data memory and SFRs. SFRs is nothing but special function registers. So on the other hand, we are having external data memory of 64 KB each. And your lower 128 bytes of internal RAM is divided into 3 parts. One is for 32 general purpose register, which is used for 4 banks, register 0, register 1, register 2 and register 3, which is of 8 bit each. And above that, we are having bit addressable area of 128 bits. Above that, we are having general purpose scratchpad area of 80 bytes. From this picture, you can easily understand the division of your 128 bytes. So lower 4 banks, above that we are having bit addressable area, above that we are having general purpose RAM. In this left side, we are having SFRs, is nothing but your special function register. Each are of working in 8-bit register. Next comes serial buffer. So serial buffer holds the byte of data when it is received or transmitted by your 8051. So the operation done using MAX 232 IC, where we are having 2 transmitter output input and 2 transmitter input output through a data pointer or data pin connector DB9. Next comes stack pointer. Stack pointer is used to point the top of the stack. So data will be stored in the stack register. Your LSB comes first and MSB comes next with using the instruction push and pop. Next comes DPTR. DPTR is data pointer. It is used to hold the address of the data. It is splitted into two halves. One is for DPL and DPH, where DPL depicts data pointer lower order byte and DPH depicts data pointer higher order byte. Next comes program status word. So PSW is also called flag register, which is used to execute the status of the microcontroller. Whatever operation done by the microcontroller, the particular status of the operation is shown by the flags. So this is of 8-bit. First one parity flag, second one user defined flag, third one overflow flag, 4 and 5 is used to select register bank, and next bit is for overflow flag, next auxiliary carry and carry flag. Next comes register PCON. PCON is what? Power control. So we are going to program our power control operation in 8051. So this is of 8-bit register. Your first bit is ideal, second bit power down mode, third and fourth bit is used for general purpose flag bits for user. 4, 5, 6 is not used, and 7 is what? Serial mode register. This is not bit addressable, this is byte addressable one. We can able to program our power so that the operation is efficient and effective one. Next comes serial control register. This is used for serial communication. This is 8-bit, and we are having TI, RI. This is for transmit interrupt flag and receive interrupt flag, and TB8, RB8 is used to transmit and receive 8-bit data. Since it is 8-bit microcontroller, we are transmitting 8-bit information to and fro through your serial register. And REN is nothing but your receiver enable. SM0, SM1 and SM2 is used to select your serial ports. We are having 4 modes of serial communication. So here mode 0 for 8 bits, 1/12 oscillator frequency baud rate, and mode 1 10 bits, which starts from start bit plus 8 data bit plus stop bit, which is variable baud rate. Mode 2 11 bit operation, start bit plus 8 data bit plus programmable 9th bit plus stop bit, programmable to either 1/32 or 1/64 oscillator frequency, and the mode 3 is 11th bit, which starts from starts bit plus 8 data bit plus programmable 9th bit plus stop bit. This is variable baud rate. Next comes T mode register. So in 8051 we are having 2 timer counter 0, timer counter 1. This particular 8-bit register is used to select timer 0, 1 or counter 0, 1. So first 4 bit is used for select timer 0, and next 4 bit is used to select counter 0. The gate signal is used to activate the particular timer which is going to select. There are 4 modes in timer counter: mode 0, mode 1, mode 2 and mode 3. So by selecting M0, M1 as 00, your mode 0 will be selected, and the description is 13-bit timer. Your timer will work for 13-bit, and if you select M1, M0 is 01, mode 1 will be selected, that is for 16-bit timer. If you go for 10, mode 2 will be selected, 8-bit auto reload, and we go for 11, mode 3 will be selected, it working as a split timer mode. Next comes your timer control register. Here we are having a control over your timing circuit. So IT0, IT1, which is used to select interrupt 0, interrupt 1 type control bit. We can able to set and clear by software to specify falling edge or low level triggered external interrupts. And we are having IE0, IE1, which is for interrupt 1 edge flag, interrupt 0 edge flag, set by hardware when external interrupt edge detector, cleared when interrupt processed. And we are having TR0, TR1, this is for run control bit timer 1 and 0, and TF0, TF1 is what? Overflow flag for timer 0 and 1. So mode will be selected using T mode, and the control over the timer operation is using by this TCON register of 8-bit. Next comes interrupt register. We know the concepts of interrupt. So if a main program is running by using your processor or controller, whatever, then if we have a subroutine called interrupt subroutine, it interrupts your main program, then the processor or controller stops the main program and stores the information in memory, and it going to perform the operation of subroutine. After executing the subroutine only, it comes back to the main program. This is the concept behind interrupt. So in 8051 we are having 8-bit interrupt register where we can able to program our interrupt. So EX0 EX1 is used to enable or disable external interrupt 1 and 0, and ET0, ET1 is used to enable or disable the timer 1 overflow interrupt, and ES is for enable or disable the serial port interrupt. If we want to disable all the interrupts of this particular register, we can able to make EA is equal to 0. If we do this EA external access or disable, no interrupts will be programmed in this interrupt register. Next comes interrupt priority register. We know the concept behind priority. Priority is giving importance to the program or function which is coming first to the microprocessor or microcontroller. This is the register which is used to program our priority. So PX0, PX1 is used to execute the priority of your external interrupt, and we have timer 0, timer 1 priority which comes after your external interrupts, and we have serial port interrupt which has a least priority than your external interrupt and timer interrupts. This is the typical digital circuit of ports. As we said, we are having 4 ports, port 0, port 1, port 2 and port 3, which comprises of buffers and driver circuits. Here the logical circuit comprises of D flip-flop, and we are having read pin, read latch and one inverter and gate, 2 MOSFETs, and we are having one switch circuit. Okay, depending upon read and writing operation in particular ports, the digital circuits working along with that control operation, address and data such a way that the controller gives or takes the data through the ports P0, P1, P2 and P3. Next come addressing modes. Addressing modes is nothing but we are programming instruction by using a structured method. So we are programming your microcontroller or microprocessor. The instructions are aligned in such a way that the processor or the controller easily fetches and understand what the instruction is going to execute. Your first type of addressing mode is immediate addressing mode. Here we are having example as move A, #0. In 8086 we are not having a hash symbol. Here we are having hash symbol for immediate mode. So that the data 0 will be moved towards your accumulator register A. And next comes your register addressing mode. Either source or destination is one of your CPU register. So here the example are move R0, A, move A, R7, add A, R4. Whatever the register we are using, but that should be only a source or destination transmission possibilities. Next comes your direct mode. We can directly transfer the data of 70H to accumulator register or the register banks R0. That is the example given below. Move A, 70H, move R0, 40H. The 70 and 40 is the direct content which is moved towards your accumulator register and R0. Next comes register indirect. The address of the source or destination is specified in registers. So here we are using example move PSW, #0, move R0, #0 cross 3C. The address of the particular data will be moved towards the register. This is register indirect. Next comes register indexed mode. Source or destination address is the sum of base address and the accumulator index. So the example move DPTR, #4000. Here your base address and the accumulator index is added so that the data will be moved towards your DPTR or accumulator register. We are having instruction sets of 8051. Each manufacturer of 8051 or 8086 developed an instruction set for the particular microprocessor chip or microcontroller chip. By using those instructions, we are going to program which is said to be an assembly language program for any applications. This is of Unit 4. Thank you.